Lesson 6.2 is all about being able to simplify, multiply, and divide rational expressions. Now remember what being rational means. Rational means that it can be written as a fraction. So our learning target is that you're going to be able to simplify, multiply, and divide rational expressions, right? Expressions that involve fractions. That's what it is. So it says simplify the rational expression, state any restrictions on the variable. So being able to simplify, really being able to simplify, multiply, divide, we're going to talk about adding. Okay, all of this is going to require you to be really good at factoring. So that's what we have to think about. So let's factor completely. That is step one. Well, 2x, I can't factor anymore, so we get 2x. Now on the bottom, how does this factor? Well, the GCF is 2x. I'm going to factor out that, and I get 2x minus 1. So now think about this. We have 2x on top, and then we have 2x times 2x minus 1. Well, you have a factor on the top and the bottom of 2x, so this simplifies to 1. So you get 1 over 2x minus 1. And now it says, talk about any restrictions on your variables. Well, remember that when you have fractions, we can never divide by 0. So when I factored this, here, right? Technically this is 2. This is 2 times x times 2x minus 1. None of those factors can be 0. Because if they were 0, then it would not be defined, right? So 2 can't be 0, that's fine. 2 can never be 0. But then we have x and we have 2x minus 1. So we have to set both of those equal to 0. So x equals 0, so x can't be 0. And then we have to set 2x minus 1 equal to 0. So add 1 to both sides, divide both sides by 2, so x is 1/2. So what are my restrictions? What can x not be? X can't be 0 or 1/2. Because if it were, then it would make the denominator 0, and we can't have that. So those two are no-goes. Those are our restrictions. All right, now we're going to multiply. So let's go ahead and factor this thing. So let's do that first. So GCF in my first numerator is 4, so I get 4 times 2y minus 1 over, what's my denominator? And remember, you guys, we multiply fractions straight across. So really, it's that times that in the numerator and that times that in the denominator. So let's just go numerator and numerator. So then what do we have? Then we've got what? We've got a GCF of 5, and this is y minus 3. Then in the bottom, my GCF of my first fraction is 5, so 2y minus 1 times next denominator has a GCF of 3, and that's y minus 3. So again, you guys remember, this is all multiplication. 4 times 5 times 2y minus 1 times y minus 3 over, I'm just putting the numbers in front, 3 times 5 times 2y minus 1 times y minus 3. And then we look for factors that we can simplify to 1. Well, 5 over 5 simplifies to 1, 2y over 2y simplifies to 1, and y minus 3 over y minus 3 simplifies to 1. So we're left with 4 over 3. But now we have to talk about our restrictions on our domain. We'll look at my factors. 5, 2y minus 1, 3, and y minus 3. So 5 and 3 don't have variables, so they'll never be 0. So now we have to look at 2y minus 1 and y minus 3. Those are going to be my restrictions. So add 1, divide by 2, so y can't be 1/2, and here, if y was 3, it would make the denominator 0. So 4/3 is my solution, and then x can't be 1/2 or 3. 5, again, let's deal with all of our factoring first. So x squared minus 4, that factors to x plus 2, x minus 2, and then we also have a factor of x plus 1 on top. And then on bottom, we have x minus 1, x plus 1 times x plus 2. because the GCF in that second denominator is x. And now let's see if we have factors on top and bottom that simplify. Well, I have an x plus 2 and an x plus 2. That simplifies to 1. Then I have an x plus 1 and an x plus 1. So those simplify to 1. So what do I now have? On top, I have x minus 2. And on the bottom, I have x times x minus 1. If you want to put that in parentheses, you can. And then we have to think about our restrictions. So what can x not be? Well, look at my factors in the bottom. I had x minus 1, x plus 1, x, and x plus 2. So we have to set all of those equal to 0. So this gives me x equals 1. This gives me x equals negative 1. I already got x equals 0 from this, and then x equals negative 2. So x can't be negative 2, negative 1, 0, or 1, because those would make your denominator 0. All right, now let's talk about division. So you multiply fractions straight across. With division, right, you have to multiply by the reciprocal. So first thing I'm going to do is I'm just going to go ahead and flip this so I don't think about it. So I have 6x plus 6y over x minus y times 5x minus 5y over 18. Now I'm going to factor what I can. So in my first numerator, I have a GCF of 6. That becomes x plus y. And then what else do I have on the top? I have times 5 times x minus y all over, I've got x minus y, and then 18, how does that simplify? 3 times 6. All right, now let's see what we've got. Anything simplify? Well, I have a 6 on top and a 6 on bottom. That simplifies to 1, and then I have a factor of x minus y and a factor of x minus y. That also simplifies to 1. So I get 5 times x plus y all over 3. And now let's talk about our domain restrictions. Okay, well, now we started with a denominator, right? We started with this denominator, which was what? 5 times x minus y. And x minus y, got that. And then we flipped it to make it 18. So really, the things we have to think about are just x minus y. X minus y, x minus y, x minus y. That's all we have to think about. So you said x minus y equal to 0, add y. So x can't be equal to positive y. That's our restriction. X can't be equal to y. Because if it is, then it would make the denominator 0. Right, let's do another division one. And I guess you guys, let's go ahead and just factor at the beginning. This factors to x plus 1, x plus 1. This factors to x plus 1, x minus 1. Okay, and now remember, we're going to multiply by the reciprocal. So we have x squared over x plus 1, x plus 1. Now we're going to multiply this by the reciprocal of that second fraction. So x plus 1, x minus 1, all over 3x. Perfect. So let's think about this. So remember x squared, and I should have done this. I'm sorry. I don't know why I didn't do this to begin with. Okay, I didn't factor this very well. X squared is x times x, and then 3x is 3 times x. So there we go. So I have an x here and an x here, so that simplifies to 1. Then I have a factor of x plus 1 and a factor of x plus 1. One on top, one on bottom, and that's it. So then I've got x times x minus 1 all over 3 times x plus 1. And now I have to think about my domain restrictions. So I have to think about all the different domains I had. So I had x plus 1, got x plus 1, that's fine. Repeats, so I need x plus 1 equals 0, x minus 1 equals 0, and then when I flipped it, I had x equals 0. So this gives me what? X equals negative 1, x equals 1, and this gave me x equals 0. So x cannot be negative 1, 0, or positive 1. Ooh, this one's going to get real complicated. All right, so I'm going to go ahead and factor first. So 6x squared times x minus 1. This factors, oh boy, what is this? 3 is the GCF. So then you get x squared minus 5x plus 4. So that factors to x minus 4, x minus 1. Then I've got x cubed times x plus 5. And then here I've got 2 times what? That would be x squared plus x minus 20, which would factor to x plus 5, x minus 4. And now I'm going to change this into multiplication. So I have 6 times x times x times x minus 1 over x times x times x times x plus 5. And we're going to multiply that by 2 times x plus 5 times x minus 4 all over 3 times x minus 4 times x minus 1. Now remember, this is multiplication, so it's just straight across. So do I have any factors on top that are also on bottom? Let's find out. I have a factor of x and a factor of x. That simplifies to 1. A factor of x, a factor of x. That simplifies to 1. A factor of x minus 1, a factor of x minus 1, factor of x plus 5, x plus 5, x minus 4, x minus 4. And now I have a 6 and a 3. So that becomes 1, that becomes 2. So then I get 2 times 2 on top, which is 4. And then on the bottom, I just have x times 1, which is just x. But now I need to state my domain restrictions. Okay, so I go back to the original. So I have x cubed, x plus 5, x plus 5, x minus 4. So x can't be 0, negative 5, 4. And then what did I get when I flipped this? I got x minus 4 and x minus 1. So I already have the 4, but I don't have the 1. So x can also not be 1. And that is your final answer. All right, last one. It looks complicated, but it's really not. Remember that this is just division. So if you want to rewrite this, go ahead. You can rewrite this as 5x squared y cubed over x minus y divided by what? 10x to the 4th y squared over y minus x. Fantastic. So I'm going to go ahead and I'm going to factor. So what do we get? And you guys, if you don't want to think about this as like x times x or y times y times y, that's okay. As long as you remember your properties of exponents. And I'm good with that. So now when I'm looking at this, you guys, these two denominators that I have right now kind of look the same. So I'm going to try to make them look more the same. So if I have y minus x, I'm going to factor out a negative 1. And if I do that, I get negative y plus x, which then gives me negative 1 times x minus y. So I have 5x squared y cubed over x minus y divided by 10x to the 4th y squared over negative 1 times x minus y. So now I'm going to go ahead and multiply by the reciprocal. So I have 5x squared y cubed negative 1 x minus y over x minus y times 10x to the 4th y squared. Right? When you multiply straight across. So I just put them all in the numerator and then all in the denominator. And now let's simplify where we can. So I have an x minus y and an x minus y. That simplifies to 1. I have a 5 and a 10, so that would simplify to 1 and 2. And then I have an x squared and an x to the 4th, so that gives me an x squared on the bottom. Then I have a y cubed and a y squared, which leaves me with just a y to the 1st on top. So then in my numerator, I have 1 times y times negative 1 over 2 times x to the 2nd, which is what? Negative y over 2x squared. And now I need to list my domain restrictions. And so we have to do them from the original and from when we flipped. So we have this denominator originally of x minus y. So x minus y equal to 0. So x equals y. So x can't be y. And then when I flipped it, this became my denominator. So x can't be 0 and y can't be 0. And that is your final answer.